beneath the deep sky where ancient stars burn in silence for millions of years, a truth waits to take your breath away. Earth, our beloved home, is nothing more than a fragile speck of dust drifting through an endless cosmic ocean. In this video, I'll take you beyond familiar boundaries to touch the true scale of the universe, with the promise that you will never see our world the same way again. Share your thoughts in the comments. How small do you think we truly are? And now, let us step into the question that opens the entire journey. How small is Earth on the scale of the 14 universe? Beneath the quiet veil of the night sky, when the lights of the world soften and the mind drifts toward deeper questions, there is a thought that gently unsettles the soul. A realization that the earth, our cradle, our story, our only witness, is almost unspeakably small in the grand pattern of the universe. Not simply smaller than the planets, not merely tiny beside the sun, but so vanishingly slight that when we set it against the larger architecture of the cosmos, it dissolves into conceptual mist. Astronomer Neil deGrasse Tyson once said, "We are a speck on a speck, orbiting a speck in the middle of a cosmic void." And somehow, the more we learn, the more indisputable that truth becomes. It begins with a simple question: how small is Earth, really? The numbers, though precise, fail to capture the sensation. They feel like cold scaffolding compared to the full emotional weight of the realization. We evolved to understand meters, mountains, miles, not light years, not galactic diameters, not the all-consuming silence between the stars. Our senses mislead us with comforting illusions, flat horizons, gentle curves, predictable skies. Standing on the shore watching waves roll toward us, Earth feels vast enough to be eternal. But the moment we lift our perspective above the clouds, the enormity of our misperception becomes clear. Earth is not the center of anything. It is not even a meaningful dot when compared to the vast cosmic structures that thread themselves across billions of light years. The first error is scale. Humans visualize Earth as a large, sturdy realm stretching far beyond our reach. Oceans do not show their boundaries, continents seem endless, and no one can walk far enough to witness the curve of the planet. Yet this illusion evaporates when placed beside the astronomical canvas. A galaxy like the Milky Way spans 100,000 light-years, while Earth spans just 12,742 kilometers. If the Milky Way were a map the size of a football field, Earth would be smaller than a single bacterium drifting unnoticed in a corner. As astrophysicist Carl Sagan remarked, "Our planet is a lonely speck in the great enveloping cosmic dark," and even that poetic image understates the difference. But to feel the scale with the heart, rather than simply quantify it with the mind, we must begin closer to home at a place where size and distance play tricks on perception. The moon. Most people imagine the moon sitting gently above Earth like a soft lantern hung in the night, a companion almost within reach. But reality paints a far lonelier picture. The moon is astonishingly far away, roughly 384,000 kilometers. If Earth were the size of a basketball, the moon would be a tennis ball hovering 7.3 meters away. Nothing between them but emptiness. A void so large that 30 Earths could be placed in a line between the two worlds without touching. We rarely imagine that distance correctly because every diagram, every schoolbook, every animation compresses the space for convenience. But the true gap is breathtaking, a silence so wide it humbles the imagination. And yet, despite this vastness, the moon's role in our story is profound and intimate. Its gravitational pull stabilizes Earth's axial tilt. Without it, our seasons would swing wildly, plunging the planet into chaotic climate cycles that could choke the possibility of complex life. Its tides sculpt coastlines, nurture ecosystems, and regulate the rhythms of entire species. Its synchronous rotation gifts us the poetic phenomenon of a near side and far side, a celestial face the world has memorized. And in the cosmic lottery, Perhaps the most miraculous coincidence of all is that the moon's diameter and its distance from Earth align so perfectly that it can exactly cover the sun, giving rise to total solar eclipses. Astronomer Fred Hoyle once noted, "There is not a single view of totality that fails to change a person's life." And indeed, the geometry that enables such an event is so precise that it feels almost like cosmic choreography. But when we zoom out again beyond Moon and Earth, into the realm of planets, the smallness deepens. Earth, with all its oceans and continents, could disappear inside Jupiter over 1,000 times. It could be swallowed by the sun more than 1,000,000 times. If Earth were a grain of sand, the sun would be a sphere the size of a house glowing with unending fire. And even the sun, mighty as it is, shrinks beside the supergiant stars. Betelgeuse would engulf Earth, Mars, Jupiter, and extend almost to Saturn. UY Scuti could swallow the entire orbit of Earth tens of millions of times over. These comparisons strain comprehension, as if language itself is too small for the truths it must convey. So why does Earth seem large to us? Because perception was shaped by survival, not by cosmic truth. Our ancestors needed to understand rivers and forests, not cosmic voids. Our eyes were built to see a few kilometers, not interstellar distances. Our intuition is a local tool, not a universal one. And so, when we try to imagine Earth's true scale, the mind rebels. It cannot reconcile daily experience with cosmic architecture. Even I, after years of studying the heavens, find myself repeatedly humbled. Every new comparison, every new calculation reopens the same awestruck silence within. The universe is not merely large, it is so large that the word loses meaning. And yet, such knowledge is not meant to diminish us. If anything, it elevates our experience. There is beauty in knowing our home is fragile. There is grace in realizing our lives unfold on a planet suspended in darkness so deep that even our sun is only a spark. And there is meaning in understanding how rare such a spark may be. Consider again the moon. Its quiet companionship is more than a poetic image. It is a symbol of the delicate alignment that allowed life to flourish. Remove it, and oceans would stagnate, climates would lurch, and Earth might fall into chaos. But with it, we have stability long enough for life to evolve consciousness capable of asking these very questions. Astronomer James Lovelock once said, "Life and Earth have grown together, like two dancers, inseparable and intertwined." And nowhere is that truer than in the Earth-Moon partnership. Reflecting on this, I am reminded that the cosmos is not hostile, it is indifferent. It owes us nothing. Every comfort we enjoy arises from a chain of impossibly fragile circumstances. And from that fragility, I draw not fear but gratitude. Perhaps the lesson is not that Earth is small, but that life is precious. Not that humans are insignificant, but that consciousness, rare as it may be, is a gift the universe seldom grants. When we gaze up and see the moon, illuminated by sunlight reflected across hundreds of thousands of kilometers, we are witnessing the delicate geometry that allowed our story to unfold. This perspective changes how I move through the world. It softens the ego. It quiets the noise. It reminds me that every argument, every worry, every ambition is taking place on a world that vanishes to nothing when placed beside a galaxy, and to less than nothing before the cosmic web. Yet that same world gave rise to poetry, to music, to love, to curiosity, to the ability to reflect on our place in the cosmos. What greater miracle could there be? So, as we drift deeper into this video, this small vessel sailing across the sea of stars, I invite you to pause with me, to breathe, to feel the space expanding outward in all directions beyond imagination, and then, gently, to return to the question that first opened this journey. How small is Earth in the scale of the universe, and what does that make us? If this reflection has stirred something in you, I encourage you to leave a comment and share your thoughts, because every perspective, every feeling, every moment of wonder is part of the story we tell together as inhabitants of this tiny world. And if you'd like to continue exploring this vast cosmic tapestry with me, consider liking or subscribing, not as a transaction, but as a quiet gesture that helps keep these meditative journeys alive. For now, let us continue slowly, softly into the deeper currents of the universe, where Earth's smallness becomes not a burden but a revelation, and where the moon's gentle pull reminds us that even in the vast silence of space, nothing exists alone. In the quiet corridors of the cosmos, where light drifts like ancient dust and time deepens into silence, there is a moment when the human mind confronts a staggering truth. Earth, our warm, familiar cradle, is astonishingly small beside the great engine that sustains us. And as we turn our gaze toward the sun, the scale of that difference blossoms into something almost spiritual. The sun is vast, beyond intuition. If Earth were a single grain of sand held gently between your fingertips, the sun would be a glowing sphere larger than a giant temple rising into the sky. Its diameter is about 109 times that of Earth, and its volume could hold 1.3 million Earths with room still left to breathe. Astrophysicist Neil deGrasse Tyson once remarked, "We are small compared with the sun, but the sun is small compared with the galaxy." And in that gentle reminder lies an invitation to step back from our narrow sense of scale and listen to the universe with quieter ears. The sun holds 99.86% of all mass in our solar system, not by accident, but by the deep, sculpting gravity of a star born in fire. During the formation of the solar system, dust, gas, and debris swirled in a primordial storm. Most of that matter collapsed into the center, heated by pressure into nuclear ignition, while the leftovers, tiny fragments compared to the star, became the planets. Carl Sagan described this with simple elegance. The cosmos is within us. We are made of star stuff, and nowhere is that truer than in the sun, whose gravity binds every world like a conductor guiding a prize. Cosmic symphony. The distance between Earth and the Sun is one astronomical unit, 1 AU, about 93 million miles. A distance so great that light, the fastest traveler in the universe, requires 8 minutes and 20 seconds to bridge it. This measurement is not simply a number. It is the foundation of celestial navigation, the ruler of interplanetary journeys, and the rhythm that shapes our seasons, our climate, and our fragile habitability. The sun creates energy through nuclear fusion, a quiet miracle unfolding in its core, each heartbeat of cosmic time. Every second, 600 million tons of hydrogen fuse into helium, releasing torrents of radiant energy that travel outward, cooling and spreading until they finally illuminate the blue surface of our world. This light is ancient. It spends hundreds of thousands of years fighting its way from the sun's core to the surface, and then, only minutes to reach Earth, like a traveler wandering in darkness, only to emerge suddenly into open sky. And Earth survives, thrives, because it orbits at the perfect distance, close enough to be warm, far enough to escape destruction. Astronomers call this the habitable zone, a delicate ring of space where liquid water can exist, where atmospheres can breathe, and where life as we know it can rise from chemistry into consciousness. Stephen Hawking once said, "We are just an advanced breed of monkeys on a minor planet of a very average star." Yet even in that humility lies wonder, because this average star provides precisely the conditions that allow us to exist at all. Now, let us drift outward. Let the solar system unfold beneath us like a great celestial garden. It stretches far beyond the orbit of Earth, beyond Mars and the gas giants, into distances so immense that normal language fractures beneath them. The solar system is mostly empty space, vast gulfs of nothingness where planets are mere punctuation marks in a cosmic sentence. This emptiness is not accidental. It arises from the early wars of gravity and angular momentum, pushing objects apart and sculpting pathways of stability where planets could survive without being torn apart. Between Mars and Jupiter lies the asteroid belt, often imagined as a dense minefield of tumbling rocks. But in truth, it is another ocean of emptiness. If you sailed through it in a spacecraft, you might never encounter a single asteroid, They are scattered like lonely islands adrift in a dark sea. Yet the belt tells a story, a world that never was. Gravitational battles with Jupiter prevented the material from forming a planet, leaving behind a fragmented museum of the solar system's earliest days. The planets themselves divide into distinct families. The inner worlds, Mercury, Venus, Earth, and Mars, are rocky, forged by heat and proximity, with solid surfaces shaped by geology and time. Beyond them rise the gas giants Jupiter and Saturn, colossal spheres of hydrogen and helium, their mass dwarfing the terrestrial planets combined. And farther still rest the ice giants Uranus and Neptune, pale blue sentinels made of water, ammonia, and methane frozen in eternal night. Each family represents a different chapter of cosmic evolution. The rocky worlds, small and dense. The gas giants, vast and tempestuous. The ice giants, remote and mysterious. And through all this variety, one truth remains. Earth is not typical. It is balanced at the edge of warmth and cold, small but not fragile, alive in a system where most worlds are sterile. Continue drifting outward, past Neptune's quiet orbit, past the dwarf planets dancing in the Kuiper belt, into a realm beyond sunlight, the Oort cloud, a spherical halo of icy bodies surrounding our solar system, stretching almost halfway to the nearest star. It is the true boundary of the sun's influence, the last breath of gravitational authority before interstellar space. Jan Oort, the astronomer who first envisioned it, once called it a great reservoir, a memory of the solar system's birth. The Oort cloud is so far away that a spaceship launched today might take millennia just to reach its inner edge. Its distances turn human imagination into vapor. But it is here, out in this darkness, that comets sleep for millions of years, waiting for gravity's whisper to send them inward, blazing like torches across our skies. A solar system this vast redefines the idea of scale. The sun dominates its center. Yet even the sun is but a spark in a galaxy of hundreds of billions of stars. And the galaxy itself is a single swirl in a universe too large for metaphor. But let us return now, gently, to that quiet blue world where our story began. A world held in balance by 1 AU of distance, by the warmth of fusion, by the emptiness that grants space for life to endure. In all our comparisons, sun to earth, planets to voids, inner worlds to outer giants, one theme emerges like a soft, insistent pulse. Earth is small, but smallness does not mean insignificance, for it is here, on this tiny oasis of rock and air, that consciousness arose. Here that atoms learned to think. Here that the universe gained eyes to see itself. As astrophysicist Brian Cox said with quiet awe, "We are the cosmos made conscious, and life is the means by which the universe understands itself." And so, when we compare Earth to the sun, or the sun to the galaxy, or the galaxy to the universe, we are not diminishing Earth. We are illuminating the improbable beauty of its existence. Earth survives because the sun shines. The solar system breathes because gravity dances, and we endure because our world occupies an exquisite sliver of space where life can whisper its fragile but persistent story. So breathe deeply now. Let the silence of the cosmos settle around you like a warm blanket. Let the scale of the sun, the distance of 1 AU, the emptiness between worlds, and the distant hush of the Oort cloud remind you of something tender and true, that even the smallest world can hold the greatest meaning. And as we drift onward through this cosmic meditation, let this truth accompany you gently, like starlight on water. We are tiny, but we are here, and that is enough. In the quiet cradle of the solar system, each planet turns like a wandering note in a cosmic symphony. Yet when we look closely, something becomes clear. They are far more different from one another than our early ancestors ever imagined. Mercury scorched and airless, Venus glowing with a fever, Earth soft and blue, Mars lonely and thin, and far beyond them the gas giants spin like swollen titans. The question whispers through the darkness: why are the planets so different? What ancient decisions of physics shape them? What forgotten storms sculpted their faces? And what truths do they reveal about our small world? Astronomer Carl Sagan once wrote that the cosmos is within us, and as we drift through these worlds with slow, thoughtful steps, we begin to see that their differences are not accidents. They are the memories of how the solar system was born. When the sun ignited 4.5 billion years ago, the newborn disk around it was full of heat, dust, and swirling gas. Near the sun, only metals and stone could survive the intense radiation. So the inner planets were forged from heavy grains, each one small, dense, and rocky. Farther out, the cold allowed lighter materials to gather. Here, hydrogen and helium could remain intact. So the giant planets drank deeply from the gas of the early disk, growing, swollen, and immense. This is why Jupiter towers over every other world, why Saturn bloats into a golden sphere. Harvard astrophysicist Dimitar Sasolov once said giant planets are the natural giants of planetary evolution. They are born where the cold is old and the gas is endless. They are planets shaped by abundance, not scarcity. But the rocky worlds closer to the sun have their own stories, each one marked by a strange and haunting signature. Take Mercury. Its surface is scarred, its rotation slow. One day on Mercury lasts 2 of its years. This slowness is not laziness, it is captivity. Over billions of years, the sun's gravity has gripped Mercury with tidal forces, dragging its spin almost to a halt, locking it in a quiet rhythm, where day and night linger like long sighs. The sun stole Mercury's freedom, and the little world never escaped its grip. Then there is Venus, a world the same size as Earth, yet burning in a furnace of its own making, its clouds thick with carbon dioxide, its pressure crushing, its heat enough to melt lead. Stephen Hawking once warned, Venus is a reminder of what happens when a greenhouse effect runs wild. And indeed, Venus whispers a terrible lesson. That similarity in size does not mean similarity in fate, that a planet can look like a sister but burn like a prophecy. Mars tells another tale. Today its air is thin, its winds weak, its rivers gone. But the ancient valleys carved into its skin tell us it was once alive with water. What happened? Its magnetic field died. Without that shield, the solar wind peeled away its atmosphere grain by grain, and with the air went the warmth, and with the warmth went the water, and with the water went the hope of a thriving world. Mars is the memory of a promise undone. Even its moon Phobos carries a secret ache, orbiting too close, spiraling inward inch by inch. It is slowly falling toward Mars. One day, perhaps 50 million years from now, it will either shatter into a ring or crash upon the red sands. A small moon, caught in a long, slow farewell. But as dramatic as the differences between planets are they pale before the distances between the stars. Here the scale of reality expands into something almost mythic. The nearest star, Proxima Centauri, is so close we call it a neighbor. Yet it is more than 4 light years away. To reach it with current technology would take tens of thousands of years, a span longer than human civilization itself. Astrophysicist Avi Loeb once said, interstellar travel requires a new physics or a patience we do not yet possess. And he is right. Space is not merely large, it is vast in a way that humbles imagination. Voyager 1 has been traveling since 1977. Sailing outward faster than any human-made craft. And yet after nearly half a century it has only just stepped into interstellar space. It has not escaped the sun's influence, only drifted to its outer shore. Its journey reminds us that even the smallest leap beyond our star is a journey of epochs. Why is space so difficult to cross? Because light itself sets the limit. Nothing can travel faster. And even light takes years to bridge the gulf between stars. It is a beautiful, cruel, absolute rule. Michio Kaku once said, the speed of light is the universal speed limit imposed by nature. It is the boundary that keeps the stars apart, the rhythm that shapes the loneliness of the galaxy. And this limit, this cosmic restraint, is the quiet force that makes the universe both reachable and unreachable. It allows us to see the stars, but not to touch them, to hear their history, but not to stand upon their worlds. Yet when we step back from the science, when we drift into the soft, meditative stillness of the cosmic view, a new understanding rises. Each planet is not a random stone, but a memory. Mercury remembers the fist of the sun. Venus remembers the fever of its sky. Earth remembers balance. Mars remembers loss. Jupiter remembers abundance. Phobos remembers falling. Voyager remembers longing. And the speed of light remembers the laws that bind the cosmos together. Their differences are the poems of creation. Their worlds are the breaths of ancient physics. In this quiet space, floating softly between stars, we can see that the diversity of planets is not chaos. It is choreography. The solar system is a dance shaped by heat, distance, magnetism, chance, and time. When you listen closely, when you let the voice slow and soften, you can feel the universe telling its own story. It says, every world carries a truth, every orbit carries a history, every silence carries a question. Why are planets different? Because difference is the language of cosmic birth. Why are the giants so large? Because cold space gives freely to those who live far from the sun. Why does Mercury turn so slowly? Because the sun holds it like a captive child. Why is Venus too hot? Because its sky became a mirror that trapped its own light. Why did Mars lose its air? Because its heart cooled and its shield fell. Why will Phobos fall? Because gravity remembers every promise. Why are the stars so far apart? Because the universe was born expanding and has never stopped. Why can we not reach Proxima Centauri? Because distances between stars are measured in lifetimes. Why does Voyager still wander near the sun? Because interstellar escape is a journey of centuries. Why is light the limit? Because nature speaks in laws that cannot be broken. And yet, in the vast darkness between these truths, there is something quietly beautiful. We, tiny creatures on a blue world, have learned to ask these questions, to understand the fates of distant planets, to measure the winds of alien skies, to listen to the whispers of ancient stars. In this ability, we find our place, not as rulers of the cosmos, but as its listeners, its dreamers, its students. So, breathe slowly. Let the universe settle into your thoughts. Feel the calm weight of its stories, and let the wonder sink in like starlight on quiet water. Because every question we ask about the planets, about the stars, about the limits of light, brings us one step closer to understanding the greatest mystery of all, why we are here, and how a small, fragile world became a place where the universe can finally know itself. We drift in the quiet arms of the Milky Way, a luminous river of stars that has circled the darkness for more than 13 billion years, and somewhere inside this swirling sea of light, on a small blue planet warmed by an ordinary star, a question rises like a soft echo. Where exactly are we? Astronomer Carl Sagan once whispered, "We live on a hunk of rock and metal, circling a humdrum star in the outskirts of a rather ordinary galaxy." And though his words sound humble, they reveal a truth that both grounds us and fills us with wonder. Because our home in the cosmos is not central, not dominant, not even particularly bright. It is simply nested, delicately and invisibly, inside one of the grandest structures the universe has ever grown. The Milky Way stretches about 100,000 light-years across, a disk of billions of suns braided into spiral arms that turn slowly like smoke. Suspended in water, among these arms lies a small spur, a minor branch sometimes forgotten on star maps, the Orion Spur. And this is where we live, not in a majestic arch of starlight, but in a quiet in-between place, a celestial suburb far from the crowded regions near the galactic heart. Our sun, glowing softly in its lonely corner, is just one among 100 to 400 billion stars. a number so large it feels like trying to grasp a handful of wind. Yet, astronomers often call the Sun average, a G-type, main sequence star, moderate in size, gentle in its light, predictable in its lifespan. To the universe, it is not special. To us, it is everything. As astrophysicist Neil deGrasse Tyson says, "We are stardust, brought to life, then empowered by the universe to figure itself out. And it is this humble star that lets us think, breathe, and look back at the galaxy that made us." The Orion's spur, our immediate neighborhood, hangs between two greater arms, Sagittarius and Perseus, like a bridge made of scattered suns, a quiet stream of stars where violent supernovae are less frequent and where life perhaps finds a safer cradle. Here, our star orbits the Milky Way's center every 225 million years, a cosmic year that outlasts the rise and fall of continents, species, and civilizations. The dinosaurs vanished only one galactic season ago. Humanity has existed for barely the blink of a cosmic eye, and if we follow the spiral inward, toward the galaxy's luminous heart, we arrive at Sagittarius A*, a supermassive black hole 4 million times the mass of our Sun, an invisible engine wrapped in luminous clouds of dust and gas. It is not a monster devouring the galaxy, but a kind of anchor, a gravitational heartbeat around which the Milky Way organizes itself. Einstein once said, "Black holes are where God divided by zero," and standing at the edge of their mystery, we understand why. Stars sling around Sagittarius A times at astonishing speeds, some approaching 5% the speed of light, their orbits revealing the hidden mass that bends space into a deep, silent well. This is the true center of the Milky Way, not a shining throne, but a shadow wearing the crown of gravity. Yet the galaxy itself is only the first step outward in our journey, for the Milky Way is not alone. It drifts with dozens of smaller companion galaxies, bound together in what astronomers call the local group. This cluster spans 10 million light-years, with Andromeda as our largest neighbor, majestic, massive, and on a slow, inevitable collision course with us. Triangulum follows, graceful and faint, and around them swarm dozens of dwarf galaxies like sparks trailing behind a comet. Astronomer Vera Rubin, who revealed the existence of dark matter, once wrote, "The universe is not only stranger than we imagine, it is stranger than we can imagine, and nowhere is that truer than in the structures that hold our local group together. Most of its mass is invisible dark matter forming halos so vast we can only trace their fingerprints in the motion of stars. If we zoom out further still, the local group becomes only a bead in a much larger cosmic necklace. The Virgo supercluster, a colossal structure containing hundreds of galaxy clusters spread across more than 100 million light-years. At its heart sits the Virgo cluster, a massive metropolis of over 2,000 galaxies, some so large, so ancient, that our entire Milky Way would seem fragile beside them. The giant elliptical galaxy M87 dominates this region. Its central black hole, famously imaged by the Event Horizon Telescope, weighs 6.5 billion suns. Here, gravity becomes architecture. Space becomes a tapestry woven from stars, gas, and invisible mass. But even this is not the end of the story. In 2014, astronomers discovered that the Virgo supercluster is not a separate island at all. It is a mere tributary flowing into an even grander river of structure. Laniakea, the supercluster of superclusters. Spanning 520 million light-years, Laniakea contains about 100,000 galaxies, all drifting, all falling subtly toward a mysterious gravitational basin known as the Great Attractor. Its pull is so vast that the entire Milky Way is moving toward it at over 600 kilometers per second. Yet the region lies in a zone obscured by the dust of our own galaxy, a cosmic blind spot called the zone of avoidance. We feel its influence, but we cannot fully see its face. Astrophysicist Brent Tully, one of the discoverers of Laniakea, noted, We are voyagers on a vast river whose current we only now begin to understand, and indeed, we are carried along by forces older and larger than imagination. Behind the great attractor lies something even more immense, the Shapley supercluster, one of the largest concentrations of galaxies in the observable universe. Its gravity tugs at Laniakea itself, a distant giant whose influence reshapes the flow of galaxy clusters, like pebbles altering the direction of a stream. The farther we look, the more we find that the universe is not random, it is structured, interconnected, shaped by gravity into patterns that resemble neural networks or spiderwebs of light. This brings us to the most breathtaking revelation of all, the cosmic web. When scientists mapped the positions of galaxies on the largest scales, they discovered not chaos, but order, a vast foam-like scaffold where filaments of galaxies stretch across hundreds of millions of light-years, separating enormous voids nearly empty of matter. It is as if the universe has grown roots and branches, as if creation itself prefers to weave its matter into threads, rather than scatter it like dust. Galaxies are the glitter on the cosmic web, cosmologist Janna Levin once said, and in truth, our entire Milky Way is only a bead of dew on a luminous, intergalactic strand. At this scale, the question of where we are becomes almost impossible to answer, for we are everywhere and nowhere at once. A tiny world circling a modest star, inside a small spur of a barred spiral galaxy, inside a local cluster, drifting within a supercluster, flowing into a greater gravitational basin, woven into a cosmic web that spans the observable universe. Every step outward reveals a larger pattern. Every pattern reminds us how small we are, and yet how precious our position is. Because in the silence between the stars, we have become observers, creatures capable of asking where we stand among the billions of galaxies and trillions of stars. Consciousness, as rare as it may be, has allowed the universe to look back at itself. And from this little corner of the Orion spur, we trace our place across the cosmic map, a journey both scientific and poetic, grounded in data yet lifted by wonder. Our true position in the Milky Way is not just a coordinate, it is a story of drifting, of belonging, of being carried by unseen currents through the grand architecture of the universe. A story that whispers, gently and constantly, that though we are small, we are not insignificant. For in the great cosmic web, where galaxies glow like lanterns on an endless night, awareness itself is the rarest light of all, and it shines here, on Earth, in us. Imagine drifting in a quiet sea of stars, where the light from ancient suns travels for billions of years before touching the human eye. Imagine the universe itself breathing slowly, as if its vastness were a kind of cosmic meditation. In that silence, a question rises like a faint pulse. Why do structures exist that should not exist at all? The Hercules Corona Borealis Great Wall, the Sloan Great Wall, the immense filaments stretching across intergalactic darkness, each of them so colossal that they seem to defy the very rules we thought governed the universe. Cosmology teaches us that structure in the universe should be limited, that gravity needs time to sculpt galaxies from primordial fluctuations, that nothing larger than about 1 billion light-years should have had enough time to form. And yet, here they are, these sprawling walls of galaxies extending across regions so enormous they almost mock our current models. As astrophysicist Subir Sarkar once said, if these structures are real, then the standard model of cosmology is in deep trouble. The Hercules Corona Borealis Great Wall, discovered in gamma-ray burst surveys, stretches an astonishing 10 billion light-years, 10 billion, nearly a tenth of the diameter of the observable universe. To call it a wall is almost misleading. It is not a barrier but a sprawling continent of galaxies, a cosmic archipelago whose scale seems more like myth than physics. Even seasoned astronomers stared at the data in disbelief, because such a structure simply should not exist under the rules of inflation and cosmic homogeneity. And yet it does. Or at least, we see something. Something that challenges the idea that matter in the universe should be evenly distributed at sufficiently large scales. The cosmological principle, the foundation of the Standard Model, rests on the belief that when you zoom out far enough, the universe becomes smooth. But these colossal structures whisper otherwise. They hint that the universe is more intricate, more textured than our equations predicted. Then there are the voids, sprawling caves of near-nothingness. The KBC void, our own local underdense region, may span 2 billion light-years, a region so empty that galaxies thin out like distant lanterns fading into fog. About 80% of the universe is composed of such voids, and it is here, in emptiness, where cosmology finds both its simplicity and its terror. Why is most of the universe empty? Because gravity sculpts matter like a slow artist. It draws dust, gas, and dark matter together, leaving behind these vast hollows. Over billions of years, the rich grow richer, the dense regions condense into filaments and clusters, while the empty regions become even emptier. The cosmic web is a tension between presence and absence, structure and silence. But this raises another question. If the universe is mostly empty, then what does that say about the small corner we can see? Why is our perspective constrained to the observable universe, a sphere roughly 93 billion light-years across? The number seems impossible at first glance. If the universe is only 13.8 billion years old, how can anything be 93 billion light-years away? The answer is gentle, patient. Space itself has been expanding, stretching, carrying galaxies away from us like leaves drifting on an ever-widening cosmic river. Light from ancient galaxies began its journey billions of years ago, but as it traveled, space continued to expand. So the distance between us now is far greater than when that light first set out. This observable limit is not a physical edge. It is not a wall or a boundary. It is simply the furthest distance light has had time to reach us. As the physicist John Wheeler wrote, time is nature's way of keeping everything from happening at once. Space is what prevents it from all happening to you. Beyond the observable universe lies more universe. How much more? We do not know. But cosmologists suspect that the real universe could be hundreds, thousands, or even infinitely times larger than what we can detect. Alan Guth, pioneer of inflation theory, once remarked, "The observable universe is just the tiniest sliver of what actually exists." If inflation occurred as we believe, then the universe could be so enormous that our 93 billion light-year bubble is barely the first grain of sand on an unimaginable cosmic shore. But infinity is not just large, it is conceptually dizzying. If the universe is infinite, then somewhere out there, the laws of probability demand that entire regions of space repeat, that there are copies of galaxies, copies of solar systems, perhaps, even copies of you, separated not by miles or years but by the unfathomable expanse of infinity. Some physicists embrace this idea, others resist it, but the possibility remains a quiet echo in the night sky. And so we return to the tension that began this meditation. Why do such enormous structures, walls, 10 billion light-years wide, exist at all? Why do such vast voids yawn across cosmic space? Why does the universe appear smooth in theory but rough and wild in practice? One answer lies in the complexity of cosmic evolution, another in the limitations of our own instruments, another still in the profound, humbling realization voiced by Nobel laureate George Smoot. When we measure the universe, we are trying to understand something far larger than our minds evolved to handle. There is beauty in that humility. For every great wall we discover, every structure that seems too vast, every void too empty, we are reminded that the universe is not obligated to fit our expectations. It is older and grander than our theories, more patient than our equations. It creates not only stars and galaxies, but mysteries, contradictions, puzzles meant to stretch the human imagination. Perhaps these gigantic structures are relics of early density ripples, frozen imprints from a time when the universe was young and chaotic. Perhaps they hint at flaws in the inflation model, or perhaps they are whispers of deeper physics we have not yet learned to name. But whatever the explanation, each discovery invites us into a deeper awe, into a softer, slower contemplation of our place in this cosmos, into the realization that we, too, are a kind of structure, small, fleeting, delicate but conscious, and consciousness, as some cosmologists like to say, is the universe learning to observe itself. When you think of the Great Walls, remember that you are looking at patterns written across billions of years, patterns so large that entire galactic superclusters cruise across them like tiny boats on an endless sea. And when you think of the voids, remember that emptiness is not loneliness. It is the negative space that allows structure to exist at all. We live suspended between these two truths, structure and void, presence and absence, light and infinite distance. The universe may be infinite, or it may not, but its mysteries are deep, enough to occupy the human spirit for eternity. In the glow of this cosmic meditation, we are reminded of the words of Carl Sagan. Somewhere, something incredible is waiting to be known. And so, we continue to look, we continue to listen, we continue to drift through the vastness, guided not only by equations, but by wonder. Because ultimately, the greatest lesson the universe offers is not about size or distance or the speed of light. It is about humility, the quiet understanding that we are small and yet capable of reaching for the infinite with nothing but curiosity and a beating heart. Close your eyes for a moment. Imagine the cosmic web stretching across the darkness. Imagine the voids, breathing softly, ancient and serene. Imagine the great walls shimmering across billions of years. You are part of this story, a brief spark in a vast ocean, and yet a spark that can think, ask, wonder, and that, perhaps, is the greatest structure of all. In the quiet hours of the night, when human worries soften and the stars return to their ancient watch, a question rises with the weight of eternity. What if our universe, the one we touch, measure, and dream within, is only one among countless others? A single bubble drifting in an infinite sea. Physicist André Lindo once whispered, "The universe is not just bigger than we think, it is bigger than we can imagine." And tonight, we drift gently into that unimaginable expanse. The multiverse, a word that tastes like myth, yet grows from the mathematics of modern cosmology, invites us to reconsider everything: who we are, where we stand, what reality even means. In its simplest whisper, the multiverse suggests that our cosmic home may be just one universe in a vast foam of universes, each expanding, colliding, or fading like waves in a timeless ocean. From this vantage point, the familiar becomes fragile. The strange becomes possible. The idea begins with eternal inflation, a theory proposed by Alan Guth and expanded by Lind. While our universe expanded rapidly after the Big Bang, inflation itself may never have ended. Instead, it may continue forever, spawning pocket universes like bubbles forming endlessly on the surface of boiling water. Each bubble may contain different physical laws, different constants, different versions of matter itself. A universe with no stars. A universe made only of dark energy. A universe where atoms never formed. And somewhere, perhaps a universe strikingly similar to ours, but never identical. Physicist Sean Carroll once said, "Eternal inflation is not a theory about what happened. It is a theory about everything that could ever happen." His words echo like a soft bell through the void, a reminder that our reality might be only a single note in a cosmic symphony too vast to hear. But if eternal inflation gives us many universes, quantum mechanics adds another twist: many versions of ourselves. In the many worlds interpretation, every quantum event branches reality into multiple outcomes. Every choice becomes a fork. Every possibility is realized somewhere in the vast quantum forest. There is a version of you who took a different job, a version who never moved hometowns, a version who never discovered astronomy, and countless versions who never existed at all. Hugh Everett, the father of this idea, wrote, "Reality is much larger than the localized experience of a single observer. In other words, what we call the universe might simply be the slice of reality we can perceive, the smallest window into a mansion with infinite rooms. Yet for all its beauty, the multiverse confronts us with a challenge. If these other universes exist, can we ever prove it? Physicists search for clues, tiny anomalies in the cosmic microwave background, cold spots in the sky that might hint at collisions between universes, gravitational signatures that defy standard models. But so far, the evidence remains subtle, tantalizing, incomplete. Nobel laureate Steven Weinberg once reflected, "Science does not require certainty, only the pursuit of the most reasonable explanation." And so, the multiverse remains a reasonable possibility, a doorway left cracked open by the equations that govern our world, not proven, not dismissed, suspended like a quiet truth waiting for a brighter instrument. But the multiverse is only one thread in our tapestry tonight. To understand the true smallness of Earth, we must leave the conceptual and return briefly to the physical, to the fiery hearts of stars. Our own sun, generous and radiant, seems enormous to us. It warms our seas. It drives our winds. It carves the rhythm of our days. Yet among the stars, the sun is simply ordinary An, average G-type dwarf, neither exceptional nor weak. As astronomer Neil deGrasse Tyson likes to remind, the universe is under no obligation to make sense to you. And indeed, it cares little for what we consider large. Below the sun in scale lie the red dwarfs, the smallest true stars. Some barely larger than Jupiter. Some so dim that a candle flame on the moon would shine brighter from Earth. Their hearts burn slowly, patiently, with lifespans stretching into trillions of years. In their presence, the sun looks almost extravagant, spending its fuel with reckless brilliance, while the red dwarfs whisper, "Slow is enduring." And above the sun lie the giant's creatures so immense that language fractures when trying to hold them. Betelgeuse, a red supergiant glowing in the shoulder of Orion, is nearly 1,000 times wider than the sun. If placed in our solar system, it would swallow Mercury, Venus, Earth, Mars, everything, out to Jupiter. Then comes Scuti, a titan among titans. A star so large that if it replaced the sun, its surface would stretch beyond the orbit of Saturn, more than 1,700 times the sun's diameter, a sphere so vast that 6 trillion Earths could vanish inside it. When confronted with such scale, our home becomes a whisper, a breath, a flicker on a cosmic ember. Astrophysicist Martin Rees once said, "Our Earth is nothing more than a tiny wet speck orbiting a run-of-the-mill star on the edge of a typical galaxy." Harsh words, perhaps, but honest, and strangely comforting. For to be small is not to be meaningless. To be fragile is not to be forgotten. The contrast between these colossal stars and our little world is not meant to diminish us. Rather, it deepens the wonder of our existence. How improbable that life arose here on a world that would fit millions of times inside a giant star. A world not central to anything. A world not favored by scale or power. Yet somehow a world that became aware of itself. When we place Earth beside stars like Scuti, size becomes irrelevant. What matters is that Earth is alive. That it hosts consciousness, something no star can claim. That on its surface, atoms learn to question the universe that made them. Astrophysicist Carl Sagan captured this truth tenderly. We are a way for the cosmos to know itself, not through mass, not through volume, but through awareness. So how do we hold these ideas together, the enormity of stars and the possibility of infinite universes? We hold them the way we hold breath, gently, with awe, with humility. The multiverse suggests we might not be alone among universes. The stars remind us how small we are within this one. and Earth teaches us that even the smallest places can cradle something miraculous. Perhaps this is the greatest lesson of all, that in a cosmos where universes may multiply endlessly and stars may grow larger than entire solar systems, meaning is not found in size. Meaning is found in experience, in curiosity, in the fragile, fleeting spark of awareness. For even if there are infinite universes, there is only one where you are listening to this one, where your consciousness floats gently through the night, absorbing the mysteries of existence. So we breathe with the stars, we drift with the galaxies, we dream with the multiverse, and in doing so, we become part of the grand tapestry we seek to understand. As your mind settles into the softness of this cosmic meditation, carry with you this final thought. We may be small, yes, we may be brief, but our ability to wonder makes us vast. Our questions stretch farther than any star. Our curiosity expands faster than any inflationary universe, and our consciousness glows more brightly than any giant. In the quiet of the night, this truth lingers like starlight. We are tiny, but we are luminous. Beneath the silent weight of the cosmos, where light from dead suns drifts for millions of years before touching our eyes, there exists a realm of stellar remnants, white dwarfs, neutron stars, black holes, objects so strange that they seem less like matter and more like whispered riddles from the fabric of space-time itself. Objects that remind us how small we are, how delicate our world is, and how unfathomably powerful the universe can be. When a star like our sun reaches the end of its long burning life, it does not explode in fury like massive stars do. Instead, it exhales softly, shedding its outer layers into a beautiful planetary nebula, and leaving behind a white dwarf, an ember glowing in the darkness. A white dwarf is roughly the size of Earth, yet holds a mass comparable to the Sun. And this paradox arises from a quantum reality called electron degeneracy pressure. As Nobel laureate Subramanian Chandrasekhar once said, "A star may collapse, but the laws of quantum physics do not." Electrons resist being squeezed into the same state, and that resistance halts the collapse, freezing the stellar core into a sphere of unimaginable density. Imagine an object no larger than our planet, yet so heavy that a teaspoon of its material would weigh several tons. Imagine an orb that shines, not by burning, but by slowly cooling across billions of years. This is the quiet, stubborn beauty of a white dwarf. But the universe, vast and restless, forges even stranger things. When a star more massive than our sun collapses, the pressure becomes too extreme for electrons to resist. Protons and electrons fuse into neutrons, and the star becomes a neutron star, a sphere no larger than a single city. Here, density reaches a scale that numbs the mind. A teaspoon of neutron star matter would weigh billions of tons, heavier than mountains, heavier than oceans. Astrophysicist Jocelyn Bell Burnell called neutron stars the most exotic state of matter in the observable universe. And she was right. These objects spin faster than helicopter blades, beam radio, pulses into space, and warp space-time like a stone dropped onto a cosmic pond. Yet, even neutron stars are not the final word in stellar death. Push gravity one step further, and space-time itself yields. The collapse continues until nothing, not light, not atoms, not time, can escape the gravitational well. This is a black hole, the purest expression of gravity in the universe. A place where matter is not destroyed, but hidden behind a horizon, its information encoded in ways we still don't understand. As physicist Kip Thorne wrote, "A black hole has no hair, only mass, charge, and spin. Everything else is stripped away. Everything else becomes mystery. And of all the black holes we know, few command awe like M87*, the supermassive black hole, whose shadow humanity imaged for the first time in 2019. M87 times is monstrous, 6.5 billion times the mass of the Sun. Its event horizon stretches wider than our entire solar system. It devours gas, dust, and even stars with a hunger written into the geometry of space-time. Its jet, a beam of plasma fired at nearly the speed of light, extends thousands of light-years into the darkness like a cosmic spear. Standing before such an object, if one could stand, you would witness gravity so intense that even time slows to a crawl. A reminder that the universe is not only beautiful, but terrifyingly deep. And yet, black holes are merely points in a larger cosmic tapestry. To understand their true scale, we must step beyond stars and into the domain of galaxies, vast cities of light drifting through the expanding dark. The Milky Way, our home, is majestic enough, about 100,000 light-years across, with hundreds of billions of stars. It feels colossal to us, but in the census of the universe, the Milky Way is only in the top 5% of galaxy sizes. Most galaxies are far smaller dwarf spheroidals, irregulars, faint clouds of starlight, barely visible even in large telescopes. Our galaxy is impressive, yes, but not exceptional. It is merely one bright pearl among trillions. Then there are giants. IC 1101, a leviathan among galaxies, spans nearly 6 million light-years, 60 times the diameter of the Milky Way. It contains over 100 trillion stars, each with their own worlds, their own histories, their own possibilities. Its core blazes brighter than thought can comfortably hold, fueled by a supermassive black hole, unimaginably larger than M87*. Theoretical physicist Michio Kaku once said, "When we talk about the universe, we are forced to use numbers that border on the poetic." IC 1101 proves this truth. It is not merely a galaxy, it is a continent of suns, a cathedral carved from starlight. And when we compare such structures to Earth, something humbling happens. Our blue planet, beautiful, fragile, bright with life, is reduced to a dust mote in a boundless cosmic desert. We measure our mountains in kilometers, our oceans in thousands of meters, but galaxies do not care for such scales. They sweep across millions of light-years while we cling to a world smaller than a spark. Here, the relativity of value becomes clear. Earth matters not because of its size, but because of what it carries: life, consciousness, memory, wonder. Carl Sagan once reflected, "The universe is not required to be in perfect harmony with our ambition." And he was right. The universe dwarfs us effortlessly, yet it is within us that the universe becomes aware. When we contemplate white dwarfs, neutron stars, and black holes, we peer into the extremes of matter. When we compare galaxies, we measure ourselves against immensity. Yet across these vast scales, one truth endures. Value is not found in size, but in meaning. The Milky Way may be dwarfed by IC 1101. Earth may be swallowed in insignificance when placed beside M87*, but no galaxy, no star, no black hole has produced a mind capable of asking what they are. No cosmic structure has questioned its own existence. We are small, yes, painfully, impossibly small, yet we contain awareness. We look at neutron stars and understand their physics. We look at black holes and measure their shadows. We look at galaxies and map their dance across billions of light-years. This is why Earth still matters, why our small world deserves reverence. Because in a universe filled with burning suns and collapsing giants, life is rare, consciousness is rarer still, and the ability to wonder is perhaps the rarest phenomenon of all. As your mind drifts through these cosmic scales, imagine yourself floating among the stars, breathing slowly, gently, as if the universe itself were exhaling. Imagine the quiet glow of a white dwarf, the furious pulse of a neutron star, the silent dominance of a black hole. Imagine galaxies sweeping past, like ancient lanterns on a dark river. And with each vision, feel your worries loosen and fade. For this is the gift of the cosmic perspective. It humbles us. It softens us. It reminds us that our lives, though small, are meaningful because they are lived here on the only world we know that sings with consciousness. Let your thoughts settle like stardust. Let the silence between the stars become the silence within you. And as we drift deeper into this journey, remember, the universe is vast, yes, but within its vastness, you are the rarest thing it has ever created, a mind capable of wonder. Earth feels immense beneath our feet, mountains rising like ancient guardians, oceans stretching beyond the horizon as if they have no end. Yet when we slip into the quiet language of physics, the scale of our world begins to dissolve. We discover a truth, both humbling and beautiful, that the solid ground we trust is woven from emptiness, that the planet we call home is built from particles, so tiny they tremble on the edge of existence. Physicist Richard Feynman once said, "Everything is made of atoms, little particles that move around in light, perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed together." His words open a doorway, a way to see Earth not as a globe of rock and water, but as a vast cathedral of atoms suspended in space. Consider a single hydrogen atom. Its diameter is roughly 1/10 of a nanometer, so small that 10 million of them could march in a line across the width of a human hair. Now imagine stacking atoms across the body of the Earth, a sphere nearly 8,000 miles wide, spinning silently through the cosmic dark. How many atoms does such a world contain? The answer stretches beyond imagination. Earth holds roughly 1.3 times 10 to the power of 50 atoms, a number so large it feels more like a spell than a measurement. And yet, each atom is mostly empty space. If the nucleus were the size of a grain of rice, sitting in the center of a cathedral, the nearest electron would be circling near the outer walls. This is the architecture of reality, a structure built from void and vibration. The earth beneath your feet is as full of emptiness as the night sky above your head. So let us ask the strange question, what if we removed all that emptiness? What if we compressed every atom of Earth until the nuclei touched, until the planet reached nuclear density? Astrophysicist Neil deGrasse Tyson once remarked, "If you squeezed all the space out of every atom in every person on Earth, our entire species would fit into the volume of a sugar cube. Apply that same cosmic violence to the whole planet, and Earth would shrink to the size of a city, a sphere only a few hundred meters across, dense enough to defy comprehension. It is a chilling image, our vast blue world reduced to something you could walk around before lunch. But this is not to diminish Earth, only to reveal a deeper layer of reality, one that flows effortlessly into the next vast idea, the scale not of matter, but of time. For the universe keeps two ledgers, one for size, one for years, and in the ledger of time, Earth is once again not the center of anything, but a brief, shimmering moment. The universe is 13.8 billion years old. Earth has existed for only 4.54 billion. We arrived late to a cosmic banquet, already halfway through its course. As astronomer Carl Sagan wrote, "We are a way for the cosmos to know itself, but we are also a way for the cosmos to remember its extraordinary age." Let us compress all cosmic history into a single year, a cosmic calendar, where the Big Bang erupts at midnight on January 1st, and the present moment rings in at midnight on December 31st. In this grand compression, the Milky Way forms in May. Our sun doesn't ignite until late August. Earth appears in early September, like a faint spark in an old lantern. Life arises swiftly, but simple and small. Bacteria humming quietly in warm oceans, and stays simple. For most of the year, not until December 17th, does complex life bloom in the oceans. Trees, insects, and fish arrive in the last days of December. Dinosaurs rule from December 25th to the early hours of December 30th. And humans? Modern humans appear at 11:52 p.m. on December 31st. All recorded human history, every kingdom, Every myth, every war, every dream carved into stone fits into the last 10 seconds of the year. It is breathtaking, our entire story condensed into a blink of cosmic time. But the universe has more story to tell, and it continues its tale, long after we are gone. One day, the sun, the warm heartbeat of our sky, will change. Stars are born, grow, age, and die, and the sun is no exception. It is halfway through its life now, a middle-aged star, burning quietly in a spiral arm of the Milky Way. But in 1 billion years, it will swell, growing brighter, hotter, more unforgiving. The oceans of Earth will hiss into steam. The air will thin. The continents will char. 5 billion years from now, the sun will balloon into a red giant, large enough to swallow Mercury and Venus, perhaps even brushing the orbit of Earth. Astronomer Brian Cox described this future with gentle precision. Stars are born, they live, and they die, and in the end, everything fades. That is the story of the universe. The sun will shed its outer layers in a shimmering nebula, then collapse into a white dwarf, a tiny, hot ember, slowly cooling for trillions of years. And Earth, if it survives the inferno, will drift as a frozen corpse through the darkening void. But even that is not the end of the story. The universe itself marches toward deeper transformations, toward eras so vast that our language falters. In the degenerate era, hundreds of trillions of years from now, stellar birth will cease. The galaxies will fade, like embers losing their glow. The last red dwarfs will exhale their final light. After that comes the black hole era, when black holes dominate the cosmos, silent, patient, devouring the remnants of everything that once lived and shone. Even they will not last forever. As Stephen Hawking famously wrote, black holes ain't as black as they are painted. They leak energy, a whisper of radiation, slowly draining their mass. Given enough time, even the supermassive giants will evaporate, a process taking 10 to the power of 100 years, a number so large it transcends imagination. And finally, in the dark era, the universe becomes a sea of cold particles wandering endlessly through an infinite night. No stars, no galaxies, no warmth, only silence. This is the ultimate horizon, a cosmos with all its candles extinguished. A universe that began in blinding light will end in perfect, eternal darkness. Yet, somehow, in the face of this staggering timeline, there is comfort. Because right now, in this fleeting, precious moment, we exist. We breathe on a world filled with oceans and forests. We stand beneath a sun that still burns strong. We look up and try to understand the place that birthed us. The atomic Earth, the cosmic year, the death of stars, the cooling of galaxies. These are not stories meant to frighten. They are stories meant to awaken, to remind us that we are part of a universe, both ancient and delicate, that consciousness is perhaps the rarest phenomenon of all. As the astrophysicist Max Tegmark wrote, "We are the universe's way of creating meaning. In a cosmos built from emptiness, we fill it with questions. In a universe ruled by entropy, we create order, art, language, love. We are small, infinitesimal, yet capable of comprehending the infinite, and that is enough to make our existence extraordinary. So let this reflection settle into you, like stardust drifting through a quiet room. Let the scales of atoms and galaxies soften the weight of the everyday, for we are children of the universe, brief sparks, but bright ones, and in our brightness, the cosmos sees itself. Close your eyes, breathe slowly, and let the universe flow through you. Because though Earth is small and time is vast, this moment, right here, right now, is a miracle suspended between atoms and eternity. There was a time when humanity lifted its eyes to the sky and believed, with innocent certainty, that everything revolved around us. A time when the sun, moon, and stars seemed like obedient lanterns pinned to a perfect dome, circling the earth in endless devotion. To our ancestors, this wasn't arrogance, but simple observation, because when you stand on a quiet field and watch the heavens wheel overhead, it truly feels as though the universe is performing a dance meant only for you. It was a comforting vision, a cosmic story where Earth was the stage and humanity the protagonist. The geocentric world was, in its own way, a cradle, warm, closed, and safe. But every cradle must eventually open. And so began one of the most profound shifts in human thought. From Earth at the center to the sun to the infinite beyond. The first cracks in the old world view appeared when Nicolaus Copernicus dared to whisper a different story. That the sun, not Earth, sat at the true center of motion. His heliocentric model was not born from rebellion, but from curiosity, from a simple desire to make sense of wandering planets that refused to follow perfect circles. Galileo followed, a quiet man with a noisy telescope, and when he aimed that small tube of glass toward the night, he discovered a universe that refused to obey old dogma. He saw the phases of Venus impossible under geocentrism. He saw moons orbiting Jupiter bodies that clearly did not circle Earth. He saw imperfections on the moon craters, shadows, rugged terrain proving that the heavens were not made of unchanging crystal, but raw, physical reality. All truths are easy to understand once they are discovered. The point is to discover them. Galileo Galilei. Yet, discovery came at a price. For revealing that Earth was not the center, Galileo was placed under house arrest. But his ideas escaped the walls that confined him. They grew, they traveled, they transformed the human mind. Still, humanity held on to one last comforting hope. If not at the center of everything, then surely we must be at the center of our galaxy. But the universe had another revelation waiting. Hubble and the shattering of the final illusion. It was not until the early 20th century that Edwin Hubble turned our world inside out once more. For through the Mount Wilson telescope, he observed that the faint nebulae in the sky were not clouds within our Milky Way at all. They were entire galaxies, island universes, hundreds of millions of light years away. With that realization, the last walls of the ancient cradle fell away. The universe is not only stranger than we imagine, it is stranger than we can imagine. Sir Arthur Eddington. And as if that weren't enough, Hubble made a second discovery that shook the foundations of reality. The galaxies were not static. They were fleeing from each other, racing outward in all directions. The universe was expanding. The universe had a beginning. The universe was far larger than anyone had dared dream. Earth was no longer the cosmic stage. It was a small, trembling grain of dust, drifting in a vast and rapidly growing ocean. And then came the silence. With each discovery, our place in the cosmos grew smaller, and naturally, a deeper question emerged. If the universe is so incredibly large, if there are trillions of galaxies, if there are more planets than grains of sand on all the shores of Earth, where is everyone? This is the heart of the Fermi paradox, the great cosmic silence that echoes louder the more we learn. Enrico Fermi once asked, during an ordinary lunch on an ordinary day, "Where is everybody?" And that simple question still haunts us. To explore it is to step into the space between awe and dread. Why? Life might be rare. Perhaps life is a miracle that blooms only under a very narrow, fragile set of conditions. Conditions so delicate that even the slightest shift makes a world barren. We know Earth needed a perfect distance from the sun, a magnetic field, plate tectonics, liquid water, stable climate, cycles, and billions of years of uninterrupted time. Break even one of those, and the story ends. As physicist Stephen Jay Gould once said, life is a glorious accident of chemistry and chance. If that is true, then perhaps intelligence is rarer still, a spark that flickers into existence, only once in a trillion possible worlds. Why civilizations might destroy themselves? Another possibility is far darker, that intelligent beings, driven by their own power and curiosity, inevitably create tools capable of ending them. Nuclear fire, engineered. Plagues, runaway technologies. These are not limitations of physics, but of wisdom. Carl Sagan warned, the first species to achieve technology becomes the first species with the capacity to extinguish itself. If this pattern holds across the cosmos, then the silence we hear may not be emptiness. It may be the echo of worlds that reach too far, too fast. Why civilizations might be quiet. Some scientists believe civilizations choose silence on purpose, fearful of attracting attention in a universe they do not fully understand. Like animals, in a dark forest, they remain hidden, waiting for others to reveal themselves first. As the physicist David Brin suggested, the galaxy may be filled with civilizations that are choosing to hush, or perhaps they communicate in ways we cannot detect, through technologies that lie beyond radio waves, beyond electromagnetic fields, beyond our current imagination. We may be deaf simply because we have not yet grown ears capable of hearing. Why distance makes contact nearly impossible. Even if civilizations thrive, even if they speak, even if they reach across the void, the distances between stars are staggeringly vast. A radio message sent to a world 500 light-years away would take 500 years to arrive, another 500 years for a reply. A single conversation would span the entirety of Western civilization. Space is not just empty, it is hostile to connection. It stretches time. It dilutes hope. It silences even the loudest shout. Perhaps the universe is not quiet. Perhaps it is simply too wide for voices to meet. A seamless reflection across time. From Earth-centered heavens to sun-centered orbits. From one galaxy to trillions. From imagined company to cosmic silence. Our understanding has unfolded like a flower in slow motion. Each step has required humility. Each revelation has required courage. And yet, with every layer of illusion we shed, something remarkable remains. Not insignificance, not despair, but wonder. Because even though Earth is small, even though civilizations may be rare, even though distances defeat our messages, we are here. We are conscious. We are capable of understanding the universe that does not revolve around us. As physicist Brian Cox beautifully said, we are the cosmos made conscious, and life is the means by which the universe understands itself. Perhaps that is the real answer to the silence. Not that the universe is empty, not that others have fallen, but that every civilization must first learn to listen inward before it learns to listen outward, toward the next horizon. So we drift onward, on our pale blue dot, armed with telescopes, equations, and dreams, searching not only the sky, but also ourselves, and maybe somewhere in the distant dark, another world is searching too, another consciousness. Wondering why the universe feels so quiet tonight. Another species asking the same question. Galileo once whispered through Venetian silence. What else is out there? And more importantly, what does our small place in this vastness truly mean? Perhaps that answer awaits us among the stars, or perhaps it has been with us the entire time. Life on Earth is a miracle wrapped in the ordinary, a quiet flame burning on a small blue world, drifting through a vast and silent universe. When we ask why life exists here, why this planet among countless worlds became a cradle of oceans, forests, minds, and dreams, we are really asking something deeper. We are asking what it means to be alive at all. We are asking why the universe chose this place to open its eyes. Scientists have long tried to explain how life began, yet the more we learn, the more mysterious the story becomes. On the early Earth, chemicals drifted in warm tides, lightning split the sky, and minerals became tiny laboratories for reactions we scarcely understand. Somewhere, in that ancient chaos, something stirred, something that could copy itself, change, survive, and try again. Carl Sagan once wrote, "Life is the universe contemplating itself." And those first molecules were the first spark of that contemplation. But how did the spark leap from simple chemistry to living biology? No one truly knows. But many believe the jump from non-life to life may not be the greatest mystery of all. The real enigma lies in what came next. For billions of years, Earth was ruled by single-celled organisms, tiny, tenacious, unimaginably successful. They were the kings of the planet, and in many ways, they still are. But then, across deep time, a transformation occurred that some consider one of the most improbable events in the history of the universe. The leap from one cell to many, from the microscopic to the macroscopic, from simplicity to astonishing complexity. The evolutionary biologist Nick Lane once said, "The hardest step of all was the transition to complex cells. Without it, there would be no animals, no plants, no us." This transition required energy, cooperation, merging lineages, and an evolutionary gamble so bold it might only happen once in a galaxy's lifetime. It was the moment Earth stepped onto a path that would eventually lead to multicellular creatures that could move, feel, learn, and dream. And yet even that miracle was not the final step. For life to become what we call consciousness, for matter to awaken to itself, another threshold had to be crossed. The neuroscientist Christoph Koch said, "Consciousness is the most astonishing thing in the universe. Nothing else comes close." Indeed, consciousness may be the rarest phenomenon of all, rarer than stable planets, rarer than liquid water, rarer than DNA itself. It is the ability of the cosmos to reflect, to ask questions, to wonder why it exists in the first place. Most of the universe is dark, cold, silent. Stars burn, planets turn, galaxies collide, but none of those things know they are happening. It is only through conscious life that the universe becomes aware. And if that consciousness is rare, if humanity is one of the few, or perhaps the only, intelligent species for billions of light years, then our role in the great cosmic story becomes more profound than we can fathom. What if we truly are alone? Not alone in a sad or hopeless sense, but alone in the sense that a tiny flame is alone in a vast, dark room. A flame that illuminates not only its surroundings but the very mystery of its own existence. Physicist Freeman Dyson once said, "In the vastness of the cosmos, the human mind is the most complex structure we know." If that is true, then our thoughts, our questions, our dreams are not small. They are extraordinary. They are precious. And with that preciousness comes responsibility. For if we are indeed the universe become conscious, if we are the only beings in this corner of the cosmos that can think, feel, and understand, then the survival of our species and the survival of the biosphere that birthed us is not merely a local matter. It becomes a cosmic duty. Imagine a universe filled with stars but lacking minds. A universe rich in beauty but without anyone to witness it. A universe full of mysteries but forever mute because no one is left to ask the questions. If humanity were to vanish, if the fragile branch of consciousness on Earth were to break, perhaps the cosmos would fall silent again, for millions or billions of years, perhaps forever. This is why Earth matters, not because of its size, not because of its place, but because of what it carries. A biosphere that arose from stardust, a chain of life unbroken for 4 billion years, and a young, curious species that looks up and wonders where it came from. Yet life is fragile. Species vanish, ecosystems collapse, climates shift, and the only planet we know that hosts life complex, conscious, curious life is changing rapidly beneath our feet. The philosopher Thomas Nagel wrote, "Without consciousness, the universe would be vastly less interesting." If that is true, then losing consciousness, losing us, would dim the universe in ways beyond measurement. So the question becomes, what do we do with this awareness? How do we carry the burden and the blessing of being perhaps the only conscious voice within a cosmic silence? First, we must understand that protecting life on Earth is not simply an environmental issue, it is a cosmic one. This planet is the only laboratory where matter has learned to think. The forests are not simply carbon reservoirs, they are part of the intricate web that allowed minds to evolve. The oceans are not just water, they are the ancient cradle where the first whispers of life began. To damage Earth is to damage the rare conditions that allow consciousness to exist. We are not just stewards of a planet, we are guardians of awareness itself. Second, we must expand our sense of time. Our species is young, barely a flicker on the cosmic calendar, yet we possess the power to imagine futures that stretch thousands or even millions of power years ahead. Astrophysicist Neil deGrasse Tyson said, "We are part of this universe, we are in this universe, but perhaps more important than both is that the universe is in us. If the universe is in us, if its history and its future flow through our veins, then our choices echo far beyond our short lifetimes. There may come a day when humanity leaves Earth, when we build homes on the Moon or Mars, when we sail among the stars using technologies we can only dream of today. If we reach that future, it will be because we protected the seedbed of life long enough to let consciousness venture outward. Earth is our origin. It may not be our destiny, but without it, we will never reach the destiny at all. Of course, perhaps we are not alone. Perhaps somewhere, orbiting a distant sun, another species looks up at its sky with the same wonder. But until we find them, until we have proof, we must act as though we are the only voice the universe has. Because if we are wrong, and life is common, we lose nothing by protecting our world. But if we are right, and consciousness is rare, then everything depends on our survival. Life on Earth is not guaranteed. Civilizations rise and fall. Species appear and vanish. But consciousness has a chance if we choose to preserve it. In this sense, the responsibility is not a burden but a calling. To care for our world, to honor the fragile spark of awareness, to ensure that the universe does not lose one of its rare moments of self-reflection. In the stillness of night, when the stars shimmer above us like ancient fires, we can feel that responsibility. We can sense the delicate thread that connects us to everything. The atoms in our bodies were forged in stars. The water in our veins once flowed through comets. The carbon in our cells once drifted through interstellar clouds. We are not separate from the universe. We are the universe made capable of memory, and memory must be protected. Understanding must be nurtured. Life must be defended not only for our sake, but for the sake of all that exists. So when we ask what makes life unique on Earth, when we wonder why consciousness arose here and perhaps nowhere else, we find ourselves faced with a profound truth. Life is not simply a feature of Earth, it is Earth's voice. It is Earth's awareness. It is Earth awakening to the cosmos and saying, "I exist." And if we are the only beings who can speak those words, then we must ensure that the whisper becomes a song, that the song becomes a legacy, and that the legacy survives long enough for the universe to hear it. For in the end, our duty is simple, yet infinite: to keep the flame alive, to carry consciousness forward, to ensure that the universe does not go blind in this corner of space, because perhaps, just perhaps, we are the only way the cosmos can know itself, and that makes every moment, every heartbeat, every breath on this small blue world unimaginably precious. The farther we drift from our small blue world, the more the universe begins to whisper a question that clings to the quiet edges of our thoughts, a question that has followed humanity from the first time we looked up at the night sky and felt something ancient awaken in us. What will become of us when the future unfolds across the stars? What path awaits a species brave enough to wonder if its destiny reaches beyond the cradle of Earth? The future of humanity is not simply about survival. It is about whether consciousness, fragile and luminous, can continue to burn against the immense darkness surrounding us. Carl Sagan once said that we are a way for the cosmos to know itself. And if his words are true, then the continuation of humanity becomes more than a biological necessity. It becomes a cosmic responsibility, a promise whispered in starlight. As we drift gently through these ideas, tonight, let your breath slow. Let the feeling of the universe settle around you like a soft midnight ocean. Imagine each sentence as a quiet wave touching the shore of your awareness. For generations, we were creatures bound to the ground, held by gravity and by the boundaries of imagination. Today, imagination still surrounds us, but gravity no longer feels as permanent as it once did. Human footprints rest in the lunar dust. Our machines glide through Saturn's rings. Our telescopes touch the edge of time. The question is no longer whether we can reach beyond Earth, but whether we can stay beyond it, live beyond it, become more than a single-world species. Elon Musk once argued that becoming multiplanetary is crucial for our long-term survival. Michio Kaku reminds us that extinction is the norm in nature, and only spacefaring civilizations endure. Their words may sound bold, but beneath them lies a quiet truth. Earth has survived cataclysms before 5 mass extinctions carved into its ancient bones. There is no law in the universe promising it will survive a 6th. To leave Earth is not to betray it. It is to carry its light into the wider night. Mars stands at the threshold of this unfolding chapter. Cold, dusty, rust-red, and yet strangely familiar, as though it were a distant cousin of Earth, waiting patiently for our arrival. Life there would not be easy. We would live under domes, breathe air spun from machines, hide from cosmic radiation, and grow food beneath artificial suns. But challenge does not diminish possibility. It sharpens it, revealing the courage hidden in our nature. And if Mars is the first step, it is not the last. Titan, with its golden haze and methane seas. Europa, hiding an ocean beneath its unbroken crust of ice. Callisto, quiet and ancient, a world where human colonies might one day float above plains untouched for billions of years. Each moon and planet in our solar family offers a different doorway to the future, a different version of humanity waiting on the other side. The moment humans live on 2 worlds is the moment our extinction becomes far less likely. A species woven across planets becomes resilient. It becomes adaptable. It becomes something larger than the fragile body of a single world. Perhaps this expansion is not destiny, but possibility, woven into the fabric of life. Seeds travel. Rivers wander. Stars drift. Why should consciousness remain still? Yet even if we succeed in reaching other worlds, another horizon looms ahead. The quiet, inevitable aging of our star. The sun, warm guardian of life for more than 4 billion years, will not shine forever. In 5 billion years it will swell into a red giant, boiling oceans, melting continents, and turning Earth into a scorched, empty memory. The universe does not mourn, it simply continues. But for the beings who formed beneath that golden light, the question becomes profound. Can intelligence outlive the death of its star? Astrophysicist Brian Cox has said that if humanity survives far into the future, we will not be living near the sun when it dies. We will have long since migrated outward, perhaps to the icy moons of Jupiter and Saturn, where warmth will still reach us faintly. Perhaps we will voyage even farther, drifting between stars like migrating birds, following habitable zones the way ancient tribes followed seasons. Perhaps we will build worlds of our own, vast stations blooming like lanterns in the dark. None of this is fantasy. It is cosmic necessity. Life that clings to a dying star disappears. With it, life that learns to wander becomes timeless. And somewhere beyond this wandering lies a deeper transformation. The human future may not be written in flesh and bone at all. Our minds may become the travelers, not our bodies. Technology, biology, intelligence, these threads may someday weave together into forms we can barely imagine. Freeman Dyson once remarked that the universe may not be hospitable to bodies, but it is hospitable to minds. If that is true, then the far future of humanity might be something diffuse, luminous, networked, an intelligence that flows through machines, data, or quantum structures. Humanity may shed its physical shape the way a butterfly leaves its cocoon, not as an ending, but as an evolution. Whether we remain biological or become something entirely new, one truth echoes beneath the surface of all these possibilities: the future of intelligence may long outlive the world that created it. Our descendants may drift between stars, live in digital realms, seed life across thousands of systems, or merge with technologies not yet imagined. The form matters less than the continuation of awareness itself. And yet, in all this cosmic possibility, one question returns like a quiet tide. If Earth is so small, almost invisible against the grandeur of galaxies and clusters, what is its true value? Why does it matter at all? The answer rests not in its size, but in its song. Earth is the only place we know where chemistry learned to breathe, where dust learned to think, where the universe learned to reflect upon its own existence. Every forest and river and creature is part of that impossibly rare symphony. Every human mind is a spark of that fragile, luminous awareness. Earth may be a speck, but it is a speck where miracles happen. On its surface, atoms arranged themselves into hearts, into memories, into dreams. Small does not mean unimportant. A heartbeat is small, a seed is small, a spark is small, and yet these tiny things hold worlds within them. The same is true for our planet. Its worth is measured not in kilometers or mass, but in the improbable beauty of life. In a universe of violent stars and empty voids, Earth is a soft whisper, a warm hand, a rare and delicate flame. Some people look at the vastness of the universe and feel diminished. But insignificance is not a scientific truth. It is only a feeling. The universe is filled with matter, but matter without awareness is silence. Consciousness is the way the universe opens its eyes, and Earth is the first place we know where those eyes opened. That makes it precious beyond measure. Some night in the future, when humans stand on Mars or drift between stars, they may look back at Earth the way we look at a childhood home, small, fragile, glowing faintly in memory. Everything we are began there. Every language, every story, every triumph and heartbreak, every dream whispered into the dark, they all trace their line back to a tiny, blue dot warmed by a gentle star. Humanity's future may stretch across planets and centuries. Earth's size may be tiny in the cosmic ocean, but the meaning of life, the meaning of being here, breathing this air, thinking these thoughts cannot be measured in light years. It is measured in experience, in connection, in the quiet miracle that consciousness arose at all. Let the universe be vast. Let galaxies stretch beyond comprehension. Let time flow for trillions of years. None of that erases the beauty of this moment or the significance of the spark that glows within us. And as you rest tonight, drifting between thought and dream, remember this: we may be small, but our story is infinite.